Hello and welcome to part 1 of paper 2 chemistry, Edexcel. Hi, I'm Laura Lewis and looking at the chemistry paper part 2 in this video series. So let's have a look. So we've got paper 2. This is a past paper, so it's a full exam paper from June 2018. The time is 1 hour 45 minutes. It says you must have a calculator and a ruler because there might be graphs and there might be things to calculate. So you always need those. You always need a pen. So let's say a black ink pen, because what happens is after you've taken the exam, it gets scanned into a computer and sent to people to mark. So I've marked things online. So people emailed the exam papers without anyone's name on it. They just emailed the paper and they mark it. Okay, but it doesn't scan very well. If your pen's too light, then they might not be able to read it. Okay, and they can't give you any marks. Okay, so total mark for this paper is 100. Answer all the questions. So even if you think you might not know, always have a go, because they don't take any marks off for a wrong answer. You can only gain marks, or if you don't write anything, you cannot get any marks. So always just have a go. Okay, because there might be something you can gain some marks for. Okay, let's start. Answer all questions. So sometimes there's a box and it tells you at the top you need to put a cross in the box. And if you change your mind, to put a line through it and then mark your answer. As long as it's clear, don't worry about neatness too much in an exam. As long as it's clear what the answer is. Okay, let's look at the first question. The Earth's atmosphere contains several gases. Figure 1 shows the relative amounts of gases thought to be in the Earth's early atmosphere. So it's not today's atmosphere, thought to be in the Earth's early atmosphere. So when the Earth formed, had an atmosphere, so the early atmosphere. So gas, oxygen, relative amounts, so they're only relative to each other. Okay, so oxygen, small amounts initially. Carbon dioxide, large amounts. There's a lot more carbon dioxide around then. Nitrogen, small amounts. Water vapor, large amounts. Okay, so just remember the early atmosphere, not the atmosphere today that's talking about. The amount of water vapor in today's atmosphere is much less than the amount in the Earth's early atmosphere. Explain why the amount of water vapor in the atmosphere has decreased. So back then the Earth was a lot hotter. Okay, so what actually happened was the Earth cooled down. So the Earth, oh, let me get my pen tool. So the Earth cooled down. The Earth cooled down. Okay. So the Earth cooled, and the water vapor condensed to form oceans. Water vapor condensed to form oceans. I'm going to give you 2 marks. That's a nice straightforward one. Remember the Earth being hot originally. The apparatus shown in figure 2 is used to find the percentage of oxygen in dry air. Syringe A, syringe B, the 2 syringes, a glass tube connecting them, copper in the middle, and heat. This is dry air. Okay, so it hasn't got any water vapor in it. So syringe A contains 50 centimeters cubed of dry air, and syringe B contains no air. Okay, there's no air in syringe B. The copper in the glass tube is heated strongly. The air in the apparatus is passed backwards and forwards over the copper until all the oxygen has been removed. Okay, so it's reacting with that copper. Initial volume of air in apparatus, 50 centimeters cubed. We were told that in the first syringe. Final volume of gas in apparatus, 40 centimeters cubed. Calculate the percentage of oxygen in this sample of dry air. Okay, percentage, so that's an important thing. It's not a mass, this is a percentage. Okay, let's underline that percentage. Some people might start answering it, but not reading the question, not taking account of percentage. So the volume of gas is nice and easy, wasn't it? Start at 50 and end at 40, so it's just 10, isn't it? Believe it or not, you actually get marks just for writing this. And you get 1 mark for just writing this. It's nice and easy. So it seems obvious to you. Okay, you get 1 mark, even if you didn't know anything else. If you just wrote that, what everyone can do, okay, see a difference, you actually get 1 mark. Okay, so the percentage, you probably do this in your head. Okay, percentage. So what percentage is it? So it's going to be like if you might work out your percentage in a test. So it's 10 divided by the total amount we put in, 50, times 100. Okay, so we would get there. Okay, so you've got the 10 divided by 50, you put would equal 20%. Okay, but remember you've also got a calculator, so I can do that in my head, but you can always do it. You can work that anyway. It's like 10 out of 50 is 20%, isn't it? As I say, because some things you can sort of work out. Okay, so it's like 20. It's like saying 20 out of 100. Okay, but don't worry too much because this is a maths paper. You can do it on a calculator. Okay, so that's 2 marks. That's nice and easy as well. But it's just about the percentage, because I think some people might try and answer with a volume or something there. Okay, but it's the percentage. Okay, so today it is about 20. That seems about right. But at the end of the experiment, the apparatus and its contents are allowed to cool before the final volume of gas is measured. The apparatus and its contents must be allowed to cool because, okay, A, reading the volume while the apparatus is hot is dangerous. B, the glass tube may crack when it is hot and allow air into the apparatus. C, the gas has expanded when it's hot. Or D, the copper reacts with other gases when the air is hot. Right, so think about that. Allowed to cool. The thing is that they want to measure the volume of gas. So it's actually because the gas, so you have a different volume of the gas when it's hot. So we need to wait for it to cool to get a room temperature volume. If you heat up a gas, it expands. Okay, still talking about the Earth. So next one. The Earth's earliest rocks contained iron sulfide and no iron oxide. Later, the rocks contained iron oxide as well as iron sulfide. Okay, explain what happened to allow this change to occur. So no iron oxide, first of all. So that means there wasn't much oxygen in the atmosphere, because iron reacts with oxygen. That's how you rust. Okay, what happens to that change to occur? So this is because oxygen increased in the atmosphere. Okay, so and iron reacted with the oxygen, or reacts, it's still left today, with oxygen. Okay, that was 2 marks. Nice, another 2 easy marks. Okay, there's nothing too hard so far. Sometimes it's just reading more the question more than it's actually, it's not a difficult answer for any of these. Okay, let's go on to the next one, number 2. A chlorine atom contains 17 electrons, 18 neutrons, and 17 protons. State the mass number of this chlorine atom. So remember, the mass number is the number of neutrons added to the number of protons. Okay, 18 plus 17 is 35. Okay, that's your answer, so underline it like that. Make sure that's clearly that's your answer. Okay. Number 2 gives the electronic configuration of this chlorine atom. So we're talking about the electrons now. Electronic, electrons. So the first shell only has 2. Okay, so 2. Then we get up to 8 in the second shell. So 2, 8, right, that's 10 altogether. We've got 7 left. The third shell can go up to 8 as well. So the 7 remaining goes in there. Okay, that's nice and easy, always an easy mark. Let's have a look at the next one. Describe what you would see if, so C, okay, so it says, let's see something happening. If damp blue litmus paper is placed into chlorine gas. Okay, chlorine gas is acidic. Okay, so it would actually turn the blue litmus paper, so let's write this down, blue litmus paper, okay, turns red, acidic, and then, because it's chlorine, that's a bleach. And then, you can get 2 marks, I think there's 2 things going to happen there. And then bleaches, it's actually the word, bleaches white. Okay, give you a mark for turns white. Well, it's a bit like if you have bleach, like for the bathroom, number one, it's quite dangerous for your skin, so don't get it near. Also, if it gets on your clothes, it will bleach them. It's got chlorine in it, so it turns them white. I remember some clothes that I had, it was like sort of like black leggings, and got some bleach on them and they turned them white. They're all spots of white, so don't get clothes or skin near bleach in the bathroom. It's not good for either of those 2 things. And when it burns your skin, number 2, it will damage your clothes as well. So I always remember that about it bleaching. Okay, let's have a look at the next thing. Also, it's not the same as hair bleach either. Hair bleach is hydrogen peroxide, which is not chlorine, so it's a different type. So it's not the same thing. Okay. So C, chlorine exists as diatomic molecules. In a molecule, 2 chlorine atoms are joined by a covalent bond. Describe what is meant by a covalent bond. Okay, so remember it's about sharing, okay, covalent bond. So a pair, so 2, we say a pair is like a pair of shoes. A pair of electrons is shared, okay, between 2 atoms. Okay. Okay. Number 2, explain why chlorine is a gas rather than a liquid at room temperature. Okay, so this is to do with the intermolecular, so forces between molecules, so intermolecular forces, okay, are weak. Actually gives you 1 mark. So boiling point, okay, is low and below room temperature. So it's already boiled, okay? That gives you the 2 marks there. Okay, part D. When the gas hydrogen chloride, HCl, is dissolved in water, a solution forms. Blue litmus paper dipped in this solution turns red. State why the litmus paper turns red. Nice. What I said earlier, the solution is acidic. Okay, so we know from earlier that answer anyway, so we've got a bonus answer here. Acidic. Okay, so it's not acidic, it's got hydrogen ions on it, okay? So it must actually also have hydrogen ions in it. Let's look at the next question. That's only 1 mark. Let's see if we can do, this one's got a bit of working out. We haven't really had any challenge to work things out yet, have we? So we've gone through that, which I mean, we need to work out. Apart from percentage, that was very straightforward. Number 3, lithium, sodium, potassium are reactive metals in group 1 of the periodic table. Sodium metal tarnishes in air, okay, so it reacts with the air to form a layer of sodium oxide on its surface. 0.92 grams of sodium combined with 0.32 grams of oxygen in this oxide. Calculate the empirical, so empirical means based on the experiment, empirical, formula of this sodium oxide. Relative masses, option 16, Na for sodium, 23. It's called Na because its Latin name is natrum for sodium. You must show you're working. Okay, so this is empirical, it's like a ratio. So let's write, we want the formula for sodium oxide, so Na and O. Okay, so we have 0.92 grams of sodium. Okay, and yeah, we're told we don't have to work that out. We're told 0.32 grams of, let's write that to make sure we know it's a mass. Right, we'll divide that by the mass, the formula mass. Okay, atomic mass, the same thing in this context. 16. Okay, that gives us 0.04. Okay, you can do it on a calculator, don't have it in your head or anything. 0.02. Okay, and then let's think about how to put that ratio. So we have 1 to something. Okay, so that one is twice of that. It's nice and easy to see this time. 2 to 1. So we have, okay, so 2 to 1. So we've got 922. So we have Na, the 2 NAs for every 1 oxygen. I know you might be able to work that out by the valency, okay, as well. But the formula is Na. But remember, sometimes when you get, especially transition metals, their valencies can change. If you ask to empirically, okay, empirically, so it's a funny word to say, it means by experiment, and you need to follow this, okay? So you need to follow the ratio. So I'm going to stop video there, and I'm going to continue in part 2. Thank you for listening. I'll see you in part 2.